Picture this. You're standing in the middle of Silicon Valley, watching a team of the world's brightest engineers frantically debug their latest AI system. The machine learning model just crashed for the seventh time today, burning through another $100,000 in compute costs. Meanwhile, 15,000 years ago, your ancestors are solving the exact same coordination problem with nothing but grunts, pointed sticks, and an algorithm so elegant that modern computer scientists are just now beginning to understand why it works. Tonight we're diving into how prehistoric cooperation algorithms beat modern AI systems. Forget everything you think you know about primitive humans being, well, primitive. This is the real story of how Stone Age hunters cracked mathematical problems that make ChatGPT look like a toddler with crayons, and trust me, you probably couldn't code your way out of their solutions if you tried. So before you get too comfortable thinking your smartphone makes you superior to cavemen, hit that like button if you enjoy having your worldview turned upside down, and let me know in the comments what year you think humans peaked intellectually. Now dim the lights, close those other browser tabs you're pretending to work on, maybe grab something stronger than coffee, and let's jump in. You wake up tomorrow morning and the internet is gone. Not down for maintenance, not slow, just gone, forever. Your first instinct is to check your phone, but of course that's useless now. Within hours, the global supply chain starts collapsing. Banks can't process transactions, power grids begin failing in cascade. Food stops arriving at grocery stores. By day 3, you and your neighbors are trying to figure out how to coordinate resource sharing without Google Docs, Slack, or even basic email. You're essentially thrown back to the Stone Age, algorithmically speaking. And here's the kicker that nobody wants to admit. Those prehistoric humans you're suddenly living like, they'd handle this situation better than you would. Not because they were tougher, though they definitely were, but because they had already solved the fundamental problem you're now facing. How do you get a group of self-interested individuals to cooperate without a central authority, without written contracts, without surveillance cameras, and without the threat of a bad Yelp review? The answer lies in something called gossip-based consensus algorithms, and if that sounds like something from a computer science textbook, that's because it is. Except humans invented it about 50,000 years before we invented computers. You see, when your great-great-great times 1,000 grandmother needed to organize a mammoth hunt, she couldn't send out a group text. She couldn't even write down who was supposed to bring the spears and who was on distraction duty. Instead, she relied on a distributed information processing system that was robust, fault-tolerant, and surprisingly efficient. Every person in the tribe was essentially a node in a network, passing information through casual conversation, evaluating the reliability of sources based on past behavior, and updating their beliefs in real time. Sound familiar? It should. It's basically how blockchain works, minus the environmental catastrophe and crypto bros. But here's where it gets really interesting. Modern AI systems, for all their computational power, consistently fail at problems that prehistoric humans solved before they invented agriculture. Take the Byzantine generals' problem, a classic computer science puzzle about reaching consensus when some actors might be unreliable or malicious. Tech companies spend millions trying to solve this with complex algorithms and machine learning. Meanwhile, a band of hunter-gatherers in prehistoric Europe solved it with nothing more than reputation tracking and strategic shunning. They didn't call it the Byzantine generals' problem. Obviously, they called it making sure Derek doesn't lie about seeing mammoth tracks again, because last time we walked for 3 days and found nothing but his stupid cousin's camp. Think about what that actually means for a second. You're essentially running a distributed database in your head, tracking the reliability scores of maybe 150 people. That's Dunbar's number if you're keeping score at home. Updating these scores based on observed behavior, cross-referencing with other people's observations, and making split-second decisions about resource allocation based on this constantly updating information. Your brain is performing operations that would make a modern data center sweat, and you're doing it while also keeping track of which berries are poisonous, and whether that rustling in the bushes is a rabbit or a saber-toothed cat. Now contrast this with how modern AI handles cooperation. Take something like multi-agent reinforcement learning, where multiple AI agents try to learn to work together. Sounds impressive, right? Except these systems regularly fail at tasks that a group of 5-year-olds could handle without breaking a sweat. Why? Because they lack what your ancestors had in spades: social intelligence, context awareness, the ability to read between the lines. An AI agent might optimize perfectly for its reward function, but it won't notice that its partner is having a bad day and adjust its strategy accordingly. It won't remember that last time this particular configuration happened, everything went sideways because Steve always hoards the resources when he's hungry. And this is where we need to talk about something anthropologists call coalitionary computation. Yeah, I know, it sounds like something a consultant made up to charge more money, but stick with me. Your prehistoric ancestors didn't just track individual relationships, they tracked coalitions, alliances, temporary partnerships, and the complex web of obligations that held their society together. They could instantly calculate things like, if I help Bob today, and Bob owes Carol from last week, and Carol's brother is good at making spear points, then I might get a better spear next month. Try programming that into TensorFlow. Go ahead, I'll wait. The really mind-blowing part is that they did all this without formal mathematics. They couldn't write down game theory equations or run Monte Carlo simulations. They just had intuition, social pressure, and the very real consequence of starving to death if they got the cooperation equation wrong. And yet they consistently outperformed what our best algorithms can do today. A group of hunter-gatherers deciding how to split up a mammoth carcass were essentially solving a multi-objective optimization problem with non-linear constraints, incomplete information, and adversarial actors. Investment banks pay people 7 figures to solve simpler problems than this, and they still need Bloomberg terminals and Excel spreadsheets to do it. But wait, you might be thinking, surely our modern systems are more efficient. We have cloud computing, machine learning, artificial neural networks that can beat grandmasters at chess. And you're right, sort of. Our systems are incredibly efficient at specific, well-defined tasks. But throw them into the messy, ambiguous, constantly changing world of human cooperation, and they fall apart faster than a Jenga tower in an earthquake. Your ancestors' cooperation algorithms, on the other hand, were anti-fragile. The more chaos you threw at them, the stronger they got. When the environment changed, when new threats emerged, when resources became scarce, these algorithms didn't need patches or updates. They adapted in real time, learning from each interaction, becoming more robust with every challenge. And here's the thing that should really make you question everything. We still use these algorithms today. Every time you decide who to trust with a secret, every time you figure out who's buying the next round at the bar, every time you navigate office politics without getting fired, you're running software that was debugged on the African savannah while dodging lions. Your brain is executing code that was optimized through millions of years of the highest stakes testing environment imaginable. Survival of the fittest wasn't just about who could run fastest or hit hardest. It was about who could cooperate most effectively. Let me paint you a picture that might hurt your modern sensibilities a bit. You're developing a new app, a revolutionary social platform that's going to change how people collaborate. You've got venture capital funding, a team of Stanford PhDs, and enough AWS credits to simulate a small country. After 18 months of development, beta testing and pivoting, you launch. Within a week, your carefully designed incentive mechanisms are being gamed by teenagers in Belarus. Your recommendation algorithm is amplifying the worst possible content. Your collaboration features are being used primarily to coordinate harassment campaigns. The whole thing is a dumpster fire, and you're hemorrhaging users faster than you can push updates. Meanwhile, 12,000 years ago, a group of humans in Göbekli Tepe, Turkey, are coordinating the construction of massive stone monuments without writing, without formal hierarchy, and without even agriculture to generate food surpluses. They're managing supply chains, scheduling labor, resolving disputes, and maintaining motivation across multiple generations of workers. Their coordination algorithm is so robust that it works across different languages, cultures, and belief systems. No product manager, no agile methodology, no Slack channels, just human cooperation algorithms running on wetware, achieving something that shouldn't be possible according to our modern understanding of project management. You want to know the really embarrassing part for us modern humans? We can't even fully explain how they did it. Our best theories involve combinations of religious motivation, feasting cycles, and competitive monument building, but we're basically guessing. We have supercomputers that can simulate protein folding and predict weather patterns, but we can't model how a bunch of hunter-gatherers organized themselves well enough to move 16-ton stones without the wheel. And before you say aliens, just stop. The aliens thing is actually insulting to human ingenuity. Your ancestors didn't need extraterrestrial help. They had something better. They had algorithms that could solve NP-complete problems through approximation and heuristics that we're only now beginning to understand. This is what I mean when I say prehistoric cooperation algorithms beat modern AI. It's not that cavemen were doing machine learning, obviously. It's that they solved the fundamental problems of coordination, trust, and collaboration in ways that our silicon-based systems still can't match. They created robust, scalable, adaptable systems that worked across different environments, different group sizes, and different resource conditions. They did it without formal mathematics, without written laws, and without the ability to A/B test their solutions. Every decision was production code. There was no rollback if something went wrong. And here's where it gets really interesting. For those of you still awake and not doom scrolling on your second screen, these prehistoric algorithms are still running in your brain right now. When you walk into a room and instantly sense the social dynamics, when you know without being told that someone's lying, when you form an opinion about someone within seconds of meeting them, that's ancient software executing. It's pattern recognition and social calculation that was refined over millions of years. Your brain is running consensus algorithms, reputation systems, and game theory calculations without you even being aware of it. You're a walking, talking distributed computing node in a network that's been running since before we invented fire. Comment below if you've ever had that moment where you just knew something was off in a social situation but couldn't explain why. That's your prehistoric cooperation algorithms at work processing social data faster than your conscious mind can keep up. These algorithms are so sophisticated that we're now trying to reverse engineer them to improve our AI systems. Tech companies are hiring anthropologists and evolutionary psychologists to understand how human cooperation works so they can build better recommendation systems and social platforms. We're literally trying to teach silicon to think like Stone Age humans because it turns out they had it figured out better than we do. Let's take a little trip, shall we? You're dropped into a hunter-gatherer band 30,000 years ago. No smartphone, no Google, no Stack Overflow to copy code from. You need to integrate into this group quickly, or you'll be tiger food by sunset. The first thing you notice isn't the lack of Wi-Fi or decent coffee, It's that everyone seems to know exactly what everyone else is doing, thinking, and planning, without anyone explicitly communicating these things. It's like they're all connected to some invisible network, sharing information through channels you can't quite perceive. Welcome to humanity's original peer-to-peer protocol, and it makes BitTorrent look like two kids with tin cans and a string. You try to contribute to the group's activities, but you quickly realize you're missing something fundamental. When the group decides to move camp, there's no meeting, no discussion that you can identify, no formal vote. People just start packing up at roughly the same time, heading in the same direction with the same apparent destination in mind. You ask someone how they knew it was time to move. They look at you like you've asked them how they know how to breathe. They just knew. Everyone knew. The information propagated through the group, through micro-expressions, body language, subtle changes in routine, and 1,000 other signals that your modern brain has forgotten how to read. You're witnessing a consensus algorithm that doesn't require explicit communication, and it's running at speeds that would make your fiber optic connection jealous. This is what computer scientists call stigmergic coordination, and ants do it with pheromones, but humans do it with something far more complex: social cues. Your ancestors developed the ability to coordinate through indirect communication, leaving behavioral traces that others could read and respond to. When someone started preparing traveling gear, others would notice and begin their own preparations. When hunters began checking their weapons more frequently, everyone knew a big hunt was being planned. No project management software needed, no status meetings, no daily stand-ups, just pure, efficient, implicit coordination that emerged from everyone running the same social algorithms. But here's where it gets really wild. This system was fault-tolerant in ways that would make modern distributed systems engineers weep with envy. If someone was sick, injured, or just having an off day, the system adapted instantly. Tasks were redistributed without anyone having to explicitly reassign them. If someone was consistently unreliable, they were gradually excluded from critical activities without any formal performance review or termination process. The system could handle bad actors, free riders, and even active saboteurs without crashing. Try doing that with your microservices architecture. And the error correction mechanisms. Oh boy, the error correction mechanisms. When wrong information entered the system, like someone misidentifying animal tracks or overestimating the distance to water, the group's collective intelligence would correct it through a process that looks remarkably like what we now call wisdom of crowds algorithms. Multiple individuals would independently assess the information. Their assessments would be weighted by their past reliability in similar situations, and a consensus would emerge that was usually more accurate than any individual assessment. They were essentially running a biological version of a Byzantine fault-tolerant consensus protocol, and they were doing it while also watching for predators and keeping the kids from eating poisonous berries. You want to know something that'll really bake your noodle? This system scaled better than most modern collaborative platforms. A band of 25 people could coordinate as effectively as a band of 150. How? Through hierarchical clustering and modular organization that emerged naturally from social dynamics. Smaller groups would form for specific tasks. These groups would coordinate with other groups through key individuals who served as bridges, and the whole system would maintain coherence without any central control. It's basically how the internet works, except they figured it out while we were still trying to evolve opposable thumbs. Now you might be sitting there in your ergonomic office chair, sipping your oat milk latte, thinking surely we've improved on these primitive systems. After all, we have Kubernetes, we have microservices, we have Agile and Scrum, and every other methodology some consultant convinced your company to adopt. But here's the uncomfortable truth that nobody in Silicon Valley wants to admit. Most of our modern collaboration tools are actually making us worse at cooperation, not better. We've replaced high bandwidth, multi-channel human communication with text messages and video calls. We've replaced implicit understanding with explicit documentation that nobody reads. We've replaced trust networks with authentication systems that everyone tries to bypass. Let me give you a concrete example that might sting a little. Your company probably uses some kind of project management software. Jira, Asana, Monday.com, pick your poison. These tools promise to make collaboration more efficient, to eliminate confusion, to ensure everyone knows what they're supposed to be doing. But what actually happens? People spend more time updating tickets than doing actual work. Information gets siloed in different tools that don't talk to each other. Critical context gets lost in endless threads of comments. The tool that was supposed to enhance collaboration becomes a barrier to it. Meanwhile, your prehistoric ancestors could coordinate a complex hunt involving dozens of people, multiple roles, contingency plans, and resource management without writing down a single word. The difference is that prehistoric cooperation algorithms worked with human nature, not against it. They leveraged our natural abilities for pattern recognition, social learning, and implicit communication. Modern systems, on the other hand, try to force us into rigid frameworks that treat humans like unreliable components that need to be managed and monitored. We've created systems that require us to explicitly state things that should be implicit, to document things that should be obvious, to track things that should be trusted. We've essentially taken a Formula One race car and replaced the engine with a hamster wheel because we don't trust the driver. But it gets worse. Our modern AI systems are learning all the wrong lessons from how we currently collaborate. We're training them on data from our broken, inefficient, trust-deficit systems. We're teaching them that collaboration means endless status updates, cover-your-ass documentation, and performative productivity. No wonder they can't figure out how to work together effectively. They're learning from us at our worst, not from the elegant solutions our ancestors developed. It's like teaching someone to cook by only showing them how to use a microwave. Here's a thought experiment for you. Imagine we could train an AI on the actual collaboration patterns of prehistoric humans, not on their tools or technologies, which were obviously limited, but on their algorithms for building trust, sharing information, reaching consensus, and coordinating action. Imagine an AI that could read social situations like a seasoned hunter reading tracks, that could build and maintain reputation networks without explicit ratings, that could adapt to changing conditions without needing its parameters retrained. That's the AI we should be building, but instead we're teaching machines to fill out forms and follow workflows. And this brings us to one of the most underappreciated aspects of prehistoric cooperation algorithms. They were energetically efficient. Your brain uses about 20 watts of power, less than a light bulb. With that 20 watts, your ancestors were running algorithms that coordinated groups, managed resources, resolved conflicts, and maintained social cohesion. A modern data center trying to solve the same problems would use megawatts of power and still not match the flexibility and robustness of human social cognition. We're literally millions of times less efficient at solving cooperation problems than a bunch of people with stone tools. The real kicker, we had the solution all along. Every human baby is born with the hardware and software to run these cooperation algorithms, but instead of developing and refining these capabilities, we suppress them. We teach kids to sit still, work independently, and communicate through formal channels. We train them to trust systems instead of people, to follow rules instead of reading situations, to document everything instead of remembering anything. You know what's really going to hurt your tech optimist soul? The more advanced our technology gets, the worse we become at the kind of cooperation that actually matters. Every generation loses a little more of the social intelligence that kept our species alive for hundreds of thousands of years. Your grandmother could probably read people better than you can. Her grandmother could do it better than her. Go back far enough and you find humans who could manage complex social dynamics that would require entire HR departments and legal teams today. Let me tell you about something anthropologists discovered that should terrify every software engineer. Hunter-gatherer societies consistently achieve better outcomes in resource distribution than modern market-based or centrally planned systems. When they share food, tools, or territory, they reach solutions that are more equitable, more efficient, and more stable than what our best economic models predict. They do this without spreadsheets, without contracts, without blockchain, without any of the tools we insist are necessary for fair distribution. They just use social algorithms that balance individual needs, group cohesion, reciprocity, and long-term sustainability in ways that would make a game theorist's head explode. And before you say that only works in small groups, let me blow your mind with something else. These algorithms scaled through what we now call small world networks. Different bands would maintain loose connections through marriages, trade relationships, and seasonal gatherings. Information and innovations could spread across entire continents through these networks faster than you'd think possible without telecommunications. The same cooperation algorithms that worked within a band also worked between bands, creating continental-scale coordination without any central authority. The spread of bow and arrow technology, for instance, followed patterns that look exactly like how memes spread on social media, except it happened 15,000 years ago. Here's where it gets really interesting for those of you who haven't rage quit to go watch cat videos yet. These prehistoric cooperation algorithms included error correction for human cognitive biases that we're only now discovering through behavioral economics. Things like loss aversion, confirmation bias, and hyperbolic discounting, which economists treat as bugs in human reasoning, were actually features in the context of small group cooperation. The algorithms accounted for these biases and used them to maintain group stability. What we call irrational behavior was actually highly rational in the context of maintaining cooperative networks. For example, the endowment effect, where people value things more just because they own them, seems irrational in market terms. But in a hunter-gatherer context, it prevented excessive trading that could destabilize resource distribution. The sunk cost fallacy kept people committed to group projects even when individual payoff was uncertain. Status quo bias prevented constant renegotiation of social arrangements. These weren't bugs to be fixed. They were features that made the whole system work. Now compare that to how modern AI systems handle cognitive biases. They either ignore them entirely, treating humans as rational actors, which we're definitely not, or they try to exploit them for engagement and profit. Neither approach leads to successful cooperation. We're building systems that either pretend human nature doesn't exist or weaponize it for extraction. Meanwhile, prehistoric cooperation algorithms worked with human nature as it actually is, biases and all, to create sustainable collaborative networks. Drop a comment if you've ever been in a situation where the official system said one thing, but everyone just knew the real solution was something else entirely. That's your prehistoric algorithms overriding modern systems, and it happens more often than you might think. Every time a team ignores the official process to get something done, every time people root around corporate bureaucracy to solve problems, every time the real decisions get made in the hallway after the meeting, that's ancient software asserting itself. We spend billions trying to suppress these behaviors with better systems and processes when we should be learning from them. Alright, let's get uncomfortable for a minute. You wake up in your climate-controlled apartment, check your phone for the 17th time since you opened your eyes, and stumble to your Wi-Fi connected coffee maker that you can control from an app, because apparently pushing a button is too much work now. You're about to start your day of remote work, collaborating with people you've never met in person through screens and software that promises to make teamwork effortless. Spoiler alert, it doesn't. In fact, you're about to spend 8 hours being less effective at cooperation than a group of Neanderthals planning a woolly rhinoceros hunt. And yes, I said Neanderthals, because even our extinct cousins had better collaboration game than your last Zoom meeting. Here's what really happened in prehistory that nobody talks about. Humans didn't become the dominant species because we were the strongest, the fastest, or even the smartest in raw computational terms. We won because we developed the most sophisticated reputation management system ever created. Every interaction, every shared meal, every hunt, every conflict was being recorded in the distributed ledger of social memory. But unlike blockchain, this ledger was fuzzy, contextual, and infinitely nuanced. Your reputation wasn't a simple number or star rating. It was a multi-dimensional matrix that included your reliability in different situations, your skills, your relationships, your past contributions, and even your potential future value to the group. Let me break down how insanely sophisticated this was. When your ancestor met someone new, their brain would instantly run calculations that would crash a modern recommendation system. They'd assess threat level, potential for cooperation, resource competition, mating potential, alliance possibilities, and about 50 other variables. All of this happened in milliseconds, using pattern matching against thousands of previous encounters, weighted by context, adjusted for current conditions, and modified by social signals from others in the group. The person would then adjust their behavior based on this assessment, which would be observed by others, incorporated into their assessments, and propagated through the social network. It was basically real-time distributed machine learning before we even invented the wheel. And this is where modern systems completely fall apart. LinkedIn endorsements, Amazon reviews, social credit scores, they're all pathetic attempts to recreate what humans did naturally for millennia. But they're missing the secret sauce: context. Your prehistoric reputation system didn't just track whether you were good or bad. It tracked whether you were good at hunting, but bad at tool making, reliable in summer but lazy in winter, trustworthy with food but not with information. It understood that reputation is situational, dynamic, and relative. Bob might be terrible at hunting, but great at mediating disputes. Sarah might be unreliable for routine tasks, but exceptional in crisis situations. The system could handle all this complexity without anyone consciously thinking about it. Now here's the part that should make every tech CEO question their entire business model. This reputation system was unhackable. You couldn't buy fake reviews. You couldn't create bot accounts to boost your standing. You couldn't game the algorithm because the algorithm was distributed across dozens of human brains, each with their own perspective and memory. Try to fake being a good hunter. You'll be found out the first time you have to actually track an animal. Claim credit for someone else's contribution. Good luck with that when everyone was there and saw what happened. The system had built-in verification through direct observation and cross-reference testimony that makes our current identity verification systems look like a kid's toy. But wait, it gets better. Or worse, depending on how attached you are to your technology. This system could handle complex moral and ethical decisions that make modern AI ethics boards look like a kindergarten philosophy class. When resources were scarce, who got fed first? When someone violated group norms, what was the appropriate response? When two people's needs conflicted, how do you resolve it? These aren't simple optimization problems. They require understanding context, history, relationships, future implications, and a dozen other factors that can't be reduced to clean data. Your ancestors solved these problems through what we might call ethical algorithms, but they were nothing like the rigid, rule-based systems we try to program into AI. They were flexible, contextual, and could balance competing values in ways that our best ethicists still argue about. A prehistoric human could instantly calculate whether stealing food from another group was justified based on the survival needs of their children, the likelihood of retaliation, the impact on future cooperation, and the precedent it would set. They'd factor in seasonal variations, past interactions, power dynamics, and potential alternatives. Then they'd make a decision that maintained group cohesion while adapting to circumstances. Try coding that into your neural network, and here's something that'll really twist your brain. They did all this while maintaining what anthropologists call egalitarian ethos. Despite having no formal laws against inequality, hunter-gatherer societies maintained remarkably flat social structures for tens of thousands of years. How? Through algorithms that detected and suppressed would-be dominators before they could accumulate power. If someone started hoarding resources or trying to boss others around, the group would deploy an arsenal of social weapons: mockery, shunning, reputation destruction, and if necessary, coordinated resistance. It was basically a distributed denial-of-service attack against authoritarianism, and it worked so well that we didn't develop rigid hierarchies until we invented agriculture and suddenly had resources worth hoarding. This is what I mean when I say prehistoric cooperation algorithms beat modern AI. Your ancestors created systems that were self-organizing, self-correcting, and self-improving without any central control or explicit programming. They handled edge cases that would crash a modern system. They adapted to new situations without needing updates or patches. They scaled from small family groups to continental trade networks without losing functionality, and they did it all while being energy efficient, fault-tolerant, and surprisingly fun. Yeah, fun. Cooperation wasn't a burden or obligation. It was woven into games, stories, rituals, and daily life in ways that made it enjoyable. When's the last time you had fun in a corporate team-building exercise? I'll wait. Now let's talk about something that modern AI completely fails at: forgiveness. Your prehistoric cooperation algorithms included sophisticated mechanisms for repairing relationships after conflicts or betrayals. When someone screwed up, and everyone screws up sometimes, the system didn't just permanently downgrade their reputation. It had pathways for redemption, rehabilitation, and reintegration. There were rituals, compensations, and social processes that allowed people to restore their standing. The system understood that zero-tolerance policies are actually terrible for long-term cooperation. Sometimes the person who betrayed you yesterday might save your life tomorrow, so you need mechanisms for rebuilding trust. Compare that to our modern systems, where one bad review can destroy a business, one offensive tweet can end a career, and one algorithmic flag can lock you out of essential services forever. We've created brittle, unforgiving systems that assume people are static entities rather than dynamic beings capable of growth and change. Your ancestors' algorithms understood that cooperation requires grace, second chances, and the ability to update assessments based on new information. They knew that today's enemy might be tomorrow's ally, and burning bridges in a world where you might need to cross them again was a survival disadvantage. But here's the really mind-blowing part. These forgiveness mechanisms weren't just feel-good social niceties, they were mathematically optimal for maintaining cooperation in repeated interactions with uncertain futures. Game theorists have recently discovered that strategies incorporating forgiveness outperform strict tit-for-tat in most real-world scenarios. Your ancestors intuited this without ever writing down a payoff matrix. They understood that the cost of maintaining grudges and feuds was higher than the cost of occasional exploitation, so they built systems that favored reconciliation over retribution. Let me paint you a picture that might make you question everything about modern progress. A band of prehistoric humans needs to decide whether to stay at their current camp or move to follow migrating herds. This decision involves processing massive amounts of information: weather patterns, resource availability, predator activity, the health status of group members, relationships with neighboring groups, spiritual considerations, and dozens of other factors. They have no spreadsheets, no data visualization, no decision matrices. Yet they consistently make better decisions than modern corporations with their big data analytics and predictive models. How? Through something called distributed cognition. The group's decision-making wasn't localized in a single leader or even a council. It was distributed across all members, with each person processing different aspects of the problem based on their expertise and perspective. The hunters noticed subtle changes in animal behavior. The gatherers tracked plant cycles. The elders remembered historical patterns. The children, yes, even the children, provided unique observations that adults might miss. All this information was integrated through discussion, storytelling, and collective sensing that produced decisions that were robust and adaptive. This is radically different from how modern AI approaches decision-making. We try to centralize all data, process it through a single algorithm, and output a definitive answer. But that's not how complex decisions actually work in the real world. There's always incomplete information, conflicting values, and unforeseen consequences. Prehistoric cooperation algorithms handled this through what we might call fuzzy consensus. Decisions emerged from the group without anyone explicitly making them. People would start preparing for a move, others would join or resist, and eventually a direction would emerge that everyone could live with. It wasn't perfect optimization, but it was robust satisficing that worked in the real world. And here's something that should worry everyone building AI systems. These prehistoric algorithms included what we now call adversarial robustness. They could handle bad actors, false information, and deliberate manipulation without catastrophic failure. If someone tried to manipulate the group for personal gain, the distributed nature of decision-making made it nearly impossible to corrupt the entire system. Multiple independent assessments, cross-validation through social channels, and the high cost of maintaining deception in a small group made gaming the system extremely difficult. Compare that to modern AI systems that can be fooled by slightly modified images or carefully crafted text prompts. But the real genius of prehistoric cooperation algorithms was their ability to balance exploration and exploitation, what computer scientists call the multi-armed bandit problem. Should you stick with known resources or explore for potentially better options? Too much exploitation and you miss opportunities. Too much exploration and you waste resources. Modern AI systems struggle with this trade-off, often getting stuck in local optima or wasting resources on endless exploration. Your ancestors solved it through a combination of individual initiative and collective wisdom. Some people were naturally more exploratory, others more conservative. The group's behavior emerged from the interaction of these different strategies, creating a portfolio approach that was both stable and adaptive. Drop a comment about a time when a group you were in just figured something out without anyone being in charge. That's these ancient algorithms at work, and they're still more effective than most formal decision-making processes. Every time a friend group decides where to eat without explicitly voting, every time a crowd navigates around an obstacle without central coordination, every time a team solves a problem through informal discussion rather than official meetings, you're witnessing the power of prehistoric cooperation algorithms. The tragedy is that we're actively dismantling these capabilities in favor of systems that are easier to monitor and control but far less effective. We replace high-trust networks with low-trust systems. We replace implicit understanding with explicit rules. We replace organic coordination with rigid processes. And then we wonder why our organizations are so dysfunctional, why our online communities are so toxic, why our AI systems can't figure out basic cooperation. We're literally coding ourselves out of capabilities that took millions of years to evolve. Time for some harsh reality. You're sitting in a meeting room, or worse, a virtual meeting room, trying to solve a problem with 7 other people. Everyone's got their laptops open, pretending to pay attention while actually checking email. Someone's sharing their screen with a PowerPoint that nobody will remember 5 minutes after the meeting ends. There's an agenda that you're already behind on, action items that won't get done, and at least 2 people who haven't said a word because they're playing corporate survival by being invisible. This is modern collaboration, and it's an insult to everything your ancestors figured out about working together. You want to know why this meeting sucks? It's because you're fighting against algorithms that have been optimized for millions of years, trying to force them into frameworks that some consultant invented last Tuesday. Let's rewind 40,000 years. A group of humans is facing a similar problem. Maybe it's deciding whether to attack a mammoth herd or figuring out how to cross a flooding river. They don't schedule a meeting. The discussion emerges organically when the relevant people are together. There's no designated facilitator, but leadership flows naturally to whoever has the most relevant expertise. People communicate through stories, not bullet points. They use metaphor and analogy, not abstract frameworks. Body language carries as much information as words. Silence is as meaningful as speech. And here's the kicker. They reach a decision that everyone understands and commits to without anyone writing down next steps or assigning action items. The difference isn't just cultural, it's algorithmic. Your ancestors' brains were running parallel processing systems that could handle multiple streams of information simultaneously. While someone was talking, others were reading micro-expressions, detecting emotional states, evaluating credibility, checking against memory, and running predictive models of different scenarios. Modern meetings try to serialize this parallel process, forcing everything through the narrow bandwidth of explicit verbal communication. It's like trying to download a movie through a dial-up modem when you have fiber optic cables sitting unused. But here's what really separates prehistoric cooperation from modern attempts. Embodied cognition. Your ancestors didn't just think about problems, they physically enacted them. Hunters would literally walk through a hunt plan, using their bodies to map out spatial relationships and timing. Gatherers would use hand gestures to indicate quantities and locations. The whole group would move together to simulate different scenarios. This wasn't primitive, it was brilliant. By engaging their motor systems in planning, they were accessing computational resources that pure abstract thinking can't reach. They were essentially using their bodies as external processors, expanding their cognitive capacity beyond what their brains alone could handle. Try this in your next corporate strategy session. Instead of sitting around a table staring at slides, get up and physically act out your business process. Use your bodies to represent different system components. Move through the space to simulate workflows. I guarantee you'll discover problems and solutions that no amount of abstract discussion would reveal. But you won't do it, will you? Because that would be weird, unprofessional, primitive. And that's exactly why your meetings are so ineffective. You've divorced thinking from doing, planning from performing, mind from body. You've literally cut yourself off from half your processing power. Now let's talk about something even more fundamental. Rhythm. Prehistoric cooperation was deeply rhythmic. Work songs, synchronized movement, shared breathing patterns. These weren't just cultural decorations. They were synchronization mechanisms that aligned neural activity across individuals. When a group moved in rhythm together, their brains would literally sync up, creating a temporary superorganism with distributed processing power. Modern neuroscience has confirmed this. Groups that move together think together more effectively, But when's the last time your team did anything rhythmic together? When's the last time you synchronized your breathing with your coworkers? Never. That's what I thought. Here's where things get really interesting for those of you who haven't fallen asleep or switched to TikTok. Prehistoric cooperation algorithms included what we now call collective intelligence amplification. When individuals work together using these ancient patterns, the group's problem-solving ability wasn't just the sum of individual intelligences, it was multiplicative. A group of average hunters could solve tracking problems that would stump the best individual tracker. A gathering party could find resources that no single gatherer would locate. The group became smarter than its smartest member, not through some mystical process, but through concrete algorithms that combine different perspectives, knowledge bases, and cognitive styles. Modern AI researchers are spending billions trying to create artificial general intelligence that can match human cognitive abilities. Meanwhile, your ancestors had figured out how to create collective intelligence that exceeded individual human abilities using nothing but social algorithms. They didn't need to build a smarter brain, they built smarter groups. And the mechanisms they used are fascinating. Cognitive diversity was actively maintained. Different personality types, thinking styles, and risk tolerances were valued because they contributed different processing capabilities to the group. The weird kid who saw patterns nobody else noticed was just as valuable as the strongest hunter. Contrast this with modern organizations that hire for cultural fit, creating homogeneous teams that all think the same way. We actively reduce our collective intelligence by selecting for similarity. We create echo chambers that amplify biases rather than cancelling them out. We mistake agreement for alignment and consensus for wisdom. Your prehistoric ancestors would look at our hiring practices and wonder why we're deliberately making ourselves dumber. They understood that cognitive friction, disagreement, and diversity weren't bugs to be eliminated, but features that improved group decision-making. But here's the part that nobody wants to hear. These prehistoric cooperation algorithms required high-trust environments to function. And I mean really high trust. The kind where you'd literally trust someone with your life, because your life actually depended on it. Modern society has systematically destroyed these high-trust environments in favor of low-trust systems that can scale. We replace trust with contracts, reputation with credit scores, relationships with transactions, and then we wonder why our cooperation systems are so inefficient. It's like replacing a fiber optic cable with a chain of people playing telephone and then wondering why the message gets garbled. The trust deficit in modern systems creates massive overhead. Think about how much time, energy, and resources we spend on verification, authentication, monitoring, and enforcement. Contracts that nobody reads, terms of service that nobody understands. Compliance departments that produce nothing but paperwork. Security systems to protect us from each other. Legal departments to sue each other. All of this is waste created by low trust. Your ancestors' high-trust systems had none of this overhead. When everyone knew everyone and reputation was everything, you didn't need lawyers to make sure people kept their promises. And this brings us to something really profound. Prehistoric cooperation algorithms were anti-fragile to technological disruption because they were based on human nature, not human tools. When new technologies appeared, like better spear points or fire-making techniques, the cooperation algorithms adapted seamlessly. The tools changed, but the underlying social dynamics remained stable. Compare that to modern systems that break every time there's a software update. We've made our cooperation dependent on specific technologies, so when those technologies change or fail, our ability to work together collapses. Remember the global IT outage I mentioned at the beginning? Your ancestors would have barely noticed. Their cooperation algorithms would have continued functioning perfectly. They might have been confused about why we were all panicking, but their ability to organize, make decisions, and work together wouldn't have been affected at all. They had robust systems. We have brittle systems. They had adaptive algorithms. We have rigid processes. They had human solutions. We have technical patches. And we call ourselves advanced. Let me tell you something that might genuinely disturb you. We are currently running a massive experiment in replacing human cooperation algorithms with artificial ones, and we have no idea what the long-term consequences will be. Every time we outsource a social function to an app, every time we let an algorithm make a decision that humans used to make, every time we replace human judgment with machine learning, we're atrophying capabilities that took millions of years to develop. It's like replacing your legs with a wheelchair when you can still walk. Sure, the wheelchair might be faster and more efficient, but use it long enough and you'll forget how to walk entirely. Your kids are growing up in a world where they might never develop these prehistoric cooperation algorithms properly. They're learning to interact through screens, communicate through emoji, and trust star ratings instead of instincts. They're not learning to read body language because everyone's on video calls with cameras off. They're not developing reputation assessment skills because everything's anonymous or pseudonymous online. They're not building high-trust networks because they're told to never trust strangers on the internet. We're literally raising a generation of humans who are cooperation disabled, and we're doing it on purpose in the name of safety and efficiency. And here's the really scary part. These algorithms aren't just nice to have social skills, they're fundamental to human survival and flourishing. Every major challenge we face, from climate change to inequality to potential AI risk, requires massive coordination and cooperation to solve. But we're systematically dismantling our ability to cooperate effectively, while simultaneously creating problems that require unprecedented levels of cooperation. It's like cutting the brake lines while driving toward a cliff and arguing about what music to play. But wait, there's more bad news. The AI systems we're building to replace human cooperation aren't just inferior, they're actively making things worse. Social media algorithms that were supposed to connect us have made us more isolated. Recommendation systems that were supposed to help us find common ground have created filter bubbles. Collaboration platforms that were supposed to make teamwork easier have made it more complicated. We're not just failing to improve on prehistoric cooperation algorithms. We're creating anti-cooperation algorithms that actively undermine human coordination. Think about what social media has done to our ability to reach consensus. In prehistoric times, disagreements were resolved through face-to-face discussion, where you could see the human cost of conflict. Now we argue with strangers through text, where every disagreement escalates because we can't see the humanity in our opponents. We've replaced nuanced discussion with binary reactions, like or dislike, upvote or downvote, follow or block. The subtle negotiations and compromises that characterize prehistoric cooperation have been replaced by algorithmic amplification of the most extreme positions. Comment below if you've ever solved a problem better in person than you could online. That's the difference between prehistoric cooperation algorithms and modern digital systems. The ancient algorithms were optimized for presence, for embodiment, for the full spectrum of human communication. Modern systems are optimized for engagement metrics, data extraction and scalability. We've traded effectiveness for efficiency, wisdom for processing speed, and relationships for connections. The solution isn't to abandon technology and go live in caves. That ship has sailed, hit an iceberg, and sunk to the bottom of the ocean. But we need to understand what we're losing and figure out how to preserve or recreate these capabilities in modern contexts. We need to design systems that augment rather than replace human cooperation algorithms. We need to create technologies that support high-trust interactions rather than assuming everyone's a threat. We need to value the kinds of intelligence that can't be measured in flops or parameter counts. So, here we are in the final stretch. And if you're still watching, congratulations. Your attention span is already better than 97% of the internet. Let's talk about what happens next. Because whether you realize it or not, we're at a crossroads that's going to determine whether humanity thrives or becomes a cautionary tale for whatever species evolves after us. We can either figure out how to integrate prehistoric cooperation algorithms with modern technology, or we can watch our civilization collapse under the weight of its own complexity while our smartphones live stream the whole thing in 4K. No pressure. The first thing we need to understand is that prehistoric cooperation algorithms aren't just historical curiosities, they're actively running in your brain right now, fighting a losing battle against systems designed to exploit them. Every notification on your phone is a hack against attention systems that evolved to notice rustling in bushes. Every infinite scroll is exploiting reward mechanisms that evolved to encourage foraging. Every social media platform is hijacking status algorithms that evolved to maintain group cohesion. We're not using technology. Technology is using us, and it's using our own prehistoric programming to do it. But here's the thing. Once you understand these algorithms, you can start to see the matrix, so to speak. You can recognize when modern systems are working against your cooperative instincts and choose to override them. That awkward feeling you get in video calls, that's your brain telling you it needs more bandwidth than pixels on a screen can provide. That exhaustion after a day of Slack messages, that's your social processing systems overheating from trying to pass text without context. That nagging sense that something's wrong with how we work together, that's millions of years of evolution screaming that we're doing it wrong. So what would it look like if we actually designed systems that worked with prehistoric cooperation algorithms instead of against them? First, we'd prioritize presence over productivity. Instead of optimizing for individual output, we'd optimize for collective intelligence. We'd create spaces and structures that allow for the kind of high-bandwidth multimodal communication that humans evolved to use. This doesn't mean getting rid of remote work, but it does mean recognizing that some types of collaboration require physical presence and designing hybrid systems that provide it when needed. Second, we'd rebuild trust infrastructure from the ground up. Instead of trying to eliminate the need for trust through verification and surveillance, we'd create systems that build and maintain trust over time. This means accepting some level of vulnerability and risk. It means allowing for forgiveness and redemption. It means recognizing that perfect security is the enemy of effective cooperation. Your prehistoric ancestors accepted that someone might betray them because the cost of preventing all betrayal was higher than the cost of occasional deception. Third, we'd embrace cognitive diversity instead of trying to standardize thinking. Modern education and corporate training are all about creating uniform outputs. People who think the same way, solve problems the same way, communicate the same way. But prehistoric cooperation algorithms thrived on diversity, different minds contributing different perspectives, different skills, different approaches. We need to stop trying to turn humans into interchangeable parts and start leveraging the unique capabilities each person brings. Now, let's get practical about how you can start applying these insights in your own life. Because sitting there nodding along isn't going to change anything. Start small. Next time you need to solve a problem with others, suggest meeting in person if possible. But don't just sit around a conference table. Walk together, move through the space. Use your bodies to model the problem. It'll feel weird at first because we've been trained to sit still and be professional, but you'll be amazed at how much more effective the discussion becomes when you engage your whole body in thinking, pay attention to your social algorithms. Notice when you instinctively trust or distrust someone. Instead of dismissing these feelings as irrational bias, examine them. What signals is your brain picking up? What patterns is it matching against? These prehistoric algorithms are processing information below your conscious awareness, and they're usually picking up on something real. That doesn't mean they're always right, but they're worth listening to. The person who gives you bad vibes might actually be untrustworthy. The project that feels doomed might actually be doomed. Your prehistoric brain knows things your rational mind hasn't figured out yet. Start building high-trust networks again. This doesn't mean trusting everyone blindly. It means investing in relationships where trust can develop over time. It means having repeated interactions with the same people, rather than constantly transacting with strangers. It means accepting the inefficiency of relationship building, because the long-term payoff in cooperation effectiveness is worth it. Your ancestors didn't have the option of ordering everything from anonymous vendors. They had to build relationships with the people they depended on, and those relationships made their cooperation algorithms work. Here's something radical. Start saying no to systems that undermine cooperation. If a tool makes collaboration harder, don't use it just because it's the standard. If a process destroys trust, refuse to follow it. If a platform amplifies conflict instead of resolving it, delete your account. Yes, there will be costs. You might miss opportunities. You might seem difficult. You might have to explain yourself, but you'll also be preserving your ability to cooperate effectively, and that's more valuable than any single opportunity or platform. And for those of you building technology, here's your challenge. Stop trying to replace human cooperation and start trying to augment it. Build systems that enhance rather than replace trust. Create platforms that support nuanced communication rather than reducing everything to binary choices. Design algorithms that bring out the best in human cooperation rather than the worst. The market might not reward you immediately, but you'll be building something that actually works with human nature rather than against it. We also need to completely rethink how we measure success. Prehistoric cooperation algorithms optimized for group survival and flourishing, not individual achievement. They measured success by whether everyone had enough, not whether someone had the most. They valued contributions that couldn't be quantified, like keeping morale up during hard times or mediating conflicts before they escalated. Our modern metrics, GDP, profit margins, engagement rates, completely miss these crucial aspects of successful cooperation. We're optimizing for the wrong things, and then wondering why our societies feel broken. But here's the really important part, and I need you to actually hear this, not just let it wash over you while you multitask. We don't have much time to figure this out. The gap between our technological capabilities and our cooperation abilities is widening every day. We're building systems that require unprecedented levels of coordination to manage safely, while simultaneously destroying our ability to coordinate effectively. It's like giving nuclear weapons to toddlers and then putting them in separate rooms where they can only communicate through crayon drawings. Let me leave you with this thought, and I want you to really sit with it after this video ends. Every single one of your ancestors, going back hundreds of thousands of years, successfully navigated the challenge of cooperation well enough to survive and reproduce. They faced predators, ice ages, famines, diseases, and countless other existential threats, and they survived them all through cooperation. The algorithms they developed are encoded in your DNA, wired into your brain, ready to be activated. You are the inheritor of the most successful cooperation technology ever developed. The question is whether you'll use it or let it atrophy while you stare at screens, pretending that likes and shares are the same as real human connection. The choice we're facing isn't between prehistoric life and modern technology. It's between systems that work with human nature and systems that work against it. We can have advanced technology and effective cooperation, but only if we stop pretending that we can engineer away millions of years of evolution. Only if we recognize that our prehistoric ancestors weren't primitive. They were sophisticated problem solvers who cracked codes. we're still trying to understand. Only if we admit that in our rush to digitize everything, we've been throwing away algorithms that actually work. So what are you going to do about it? Are you going to keep participating in systems that make cooperation harder? Are you going to keep pretending that digital connections are as good as real relationships? Are you going to keep letting algorithms decide who you trust, who you talk to, and how you work together? Or are you going to start reclaiming your evolutionary inheritance? Are you going to start building high-trust networks again? Are you going to start using your full cognitive capacity, body and mind, to solve problems with others? Here's my challenge to you. Tomorrow, try one prehistoric cooperation technique. Have a walking meeting, build consensus without voting, solve a problem through storytelling instead of spreadsheets. Trust your instincts about someone instead of checking their LinkedIn. Share something without expecting exact reciprocation. Whatever you choose, pay attention to how it feels. Notice if it works better than your usual approach, and then come back and tell me about it in the comments, because I genuinely want to know what happens when people start remembering how to cooperate like humans instead of machines. The truth is, we're not going to solve the challenges ahead with better AI or faster processors or more sophisticated algorithms. We're going to solve them the same way our ancestors solved their challenges, through cooperation, through trust, through the messy, inefficient, beautiful process of humans working together despite their differences. The algorithms we need aren't in some future technology, they're already in our heads, waiting to be used. We just need to remember how to run them. And look, I know this whole video has been a bit of a downer, pointing out all the ways modern systems are failing us. But here's the optimistic part. These prehistoric cooperation algorithms are anti-fragile. They've survived ice ages, plagues, wars, and Windows Vista. They're still there, still functional, still ready to work. Every time you successfully collaborate with someone, every time a group reaches consensus without formal structure, every time humans coordinate without central control, these algorithms are proving they still work. We haven't lost them. We've just buried them under layers of unnecessary complexity. So there you have it. Prehistoric cooperation algorithms beat modern AI systems not because our ancestors were smarter than us, but because they solved the right problems in robust ways. They built systems that worked with human nature rather than against it. They created algorithms that were anti-fragile rather than brittle. They optimized for group success rather than individual achievement. And most importantly, they recognized that cooperation isn't a technical problem to be solved, but a human capacity to be cultivated. If you made it this far, you're already better at sustained attention than most of the internet. So drop a comment about what surprised you most, like this video. If it made you think differently about human cooperation, subscribe if you want more deep dives into how ancient wisdom beats modern technology. And remember, the next time someone tells you that AI is going to replace human intelligence, remind them that we haven't even figured out how to match what humans achieved with stone tools and social algorithms. Until next time, stay curious, stay critical, and maybe try trusting your prehistoric instincts once in a while.